So to do all of these experiments, you would need typically a simple digital multimeter, and its operations are pretty simple. You have, the one that I have is a pretty old version, but it's mostly sufficient for most of the experiments. You can measure DC voltage, you can measure AC voltage, DC amperes, and resistance, etc. Okay, so we learned in the last video that we can use a circuit like this to ensure a 5 volt supply or a 3.3 volt supply. Today we'll go ahead and make a simple circuit, our first circuit. So the components for the circuit is an LED and a resistor. Now a resistor needs to be read in terms of its resistance. So as per the chart shown earlier, resistance can be read by reading the colors on the rings, by noting the colors on the rings. For example, this one is a brown followed by a black followed by a red ring and then followed by a golden brown ring. So the value of this can be very easily determined from the image shown earlier. So the brown stands for 1, the black stands for 0, and then the red stands for a multiplier of 2, 10 to the power 2, which means the value of this resistance is 1, 0 into 10 to the power 2, which is 1 kilo ohms. So we'll fix this. So a resistor is non-directional, which means that you really need not worry about which is plus and which is minus. You could either have it this way or that way. Both are. You really don't matter. You don't really care whether you need to attach this to the plus side or the other one to the plus side. Both are. So it's basically non-directional. So we connect our resistor, say on E20, and we connect the other end to say E30. So I have now a circuit with a resistor and voltage which I have not yet connected. So let me connect the voltage. So the voltage is 5 volt or 3 volt. So I have enabled the voltage, and I also have an LED. So I have a VCC, I have an LED, and I have a resistor. So to complete the circuit, let me add the LED. An LED is a directional device or a component. You can see one of the legs of the LED is longer than the other leg. So you can safely assume this leg is positive and this leg is negative. So I will connect this to the row D. So I need to connect. So I am assuming this is the plus. So I say let me connect it to D35. D35 is this one. And the other end I connect to D30. So what this means is D30 and E30 are connected. So which means the negative end of the LED is connected to the resistor. The positive end is floating. There is no other connection there. the other end of the resistor is also floating. There is no other connection there. Now we need a couple of jumper wires to kind of complete the circuit. So as you can see, this has a voltage, this has a resistor, and this has an LED. Utilizing the jumper wires, we will connect, say let's use the 5 volt supply first. So we'll connect the 5 volt to, we are connecting to the row number C, but you see that it will be in the same circuit because it will connect to the positive end of the LED. But the circuit is still not complete. So if you see, this is the VCC line going up, so this is a positive line that goes all the way through. It goes to the positive of the LED, it goes across the negative of the LED to the resistance, but the end of the resistance is not connected to the ground, so the circuit is not complete. So we use the other jumper wire and connect, say, the negative with the negative, and instantly you see the LED is switched on. So utilizing the multimeter, let's quickly check the voltage differences across. So the LED, the voltage difference across is 2.43 volts, and the voltage difference across the resistance is 2.6 volts. In reality, the 5 volt supply got distributed across the LED and the resistance. So the total value of the voltage across should be 5 volts. Let's just quickly check that. I'll remove the two ends, and I connect the negative. So you see it's 5.04 volts. So the voltage got distributed across the LED and the resistance. Thanks.